Hi, I hope everyone is doing fine and is safe during the last events. Our video today is going to be about lean manufacturing layout. The outline is as follows. First, we will be talking about layout strategies, including a scope of operations layout and production line layout. Then layout shapes. We'll be focusing on what shapes lean manufacturing layout can take. Lastly, lean layout. What is it? How to create it? The goal is relatively simple. Develop a lean manufacturing system to streamline production and ensure a smooth flow for work, material, and information. In the world of manufacturing, time is money. An effective facility layout ensures efficient use of labor, eliminates bottlenecks, provides proficient communication between workers and supervisors, eliminates downtime, ensures material and product continual flow, ensures that performance metrics can be monitored in real time, and provides flexibility for future workflow changes. The scope of operations layout is determined by selecting the range of products and process span. The range is usually decided on by a product's make versus buy strategy for all components and products in the chain. A simple facility type is one where the range of products, processes and/or customers is small and easy to determine. Otherwise, common product or process characteristics determine the type of layout. Product quantity analysis indicates the probable facility type by grouping items depending on volume. High volume items need a production line layout. Medium volume items need cellular layout. Low volume items need a multiple routing cell layout. Transfer line layout arranges activities in a production line according to a sequence of operations that need to be performed to assemble a particular product. This layout requires that materials be moved in one direction along the assembly line and always in the same pattern. The major concern for the product layout design is balancing the assembly line so that no one's workstation becomes a bottleneck. The product layout efficient and easy to use, but it is inflexible. Tesla uses a U-shaped layout in its factory which is efficient in space utilization and also gives visibility on the production line. It also makes the input and output sections next to each other, making the design of the receiving and shipping way easier. In a U-shaped line you can even share equipment for different product lines more easily, saving costs on duplicate machines. Hundreds of parts and sub-assemblies are bolted onto and into the vehicles as they move down a linear production line that has been selectively automated to eliminate ergonomically incorrect tasks and the need to lift heavy parts, or simply to speed up the process. A U-layout eliminates the required space for work in progress WIP, makes implementation of teamwork easier as team members work closer to each other, increases the ability of operators to work on more than one machine or workstation. General assembly is where the painted body of the car gets all the components we interact with like wiring, dash, carpet, center console, seats, etc. In the Model 3 general assembly lines, the balance of automation versus human effort had clearly been worked out as Tesla sought to make the assembly process not only faster and more predictable, but also more friendly for humans. Generally speaking, Tesla found that machines are great at working with parts that are always the same size and in the same place, like metal, bolts, batteries, battery packs, hard plastics, and such. The Model 3 body line is 90 automated and has over 1,000 robots. When it comes to working with fabrics, belts, wires, and the like, humans are better. Tesla takes its vehicles all the way from rolls of aluminum to completed vehicles at its factory, so its layout has to be immaculate. For example, Tesla got the massive Schuler high-precision high-throughput press for stamping out body panels for the Model 3. Tesla made numerous improvements to the press to increase productivity. They completely reworked the conveyors to fit more functionality into less space. They did this by replacing the 2 discharge conveyor belts that came with the press with 4 shorter belts that fit better into their space. The I-shaped layout are best for processes with a small number of steps. Often I-shaped layouts are used for final assembly and are fed by sub-assembly cells producing short lead times and small footprints. Several I-shaped layouts can be arranged in parallel for different products or feeding into a central flow. A lean plant layout applies lean manufacturing principles to cut wastes, lower costs, achieves higher quality and standardization, shortens lead time. Lean facilities create a seamless flow for information and minimize handling time and effort. So what's the difference between traditional and lean plant layouts? Traditional plant layout focuses more on process-based departments. Similar machines are grouped into functional work centers or workshops. A typical traditional machinery factory might be separated into workshops of cutting, fabrication, machining, and assembly. Usually, there are walls between these different workshops, and materials are transported between departments by forklifts. To make production more economical, work is often done in batches, in the name of economic batch quantity. This leads to high levels of work in process inventory and long lead times. Lean plant layout focuses on value streams, all value-added steps from raw materials until the delivery to your customer. Lean layouts are more likely to combine processes horizontally across the factory, compared to vertical process departments like silos in a traditional facility layout. With a lean layout, different machines tend to be grouped by product families, a group of products that passes through common processes or equipment and they have similar work content. As the processes are connected in a lean layout, much less material handling is required. Suffering from massive inventory between processes and several accidents with the forklift, one plant manager set no forklift on the shop floor as the goal for their new plant layout. The lean layout reduced material handling dramatically, forklifts were not required anymore, batch sizes were reduced. This led to less work in process inventory and shorter lead times. Most manufacturers have several large machines that are keys to the quality and cost of the product. The traditional mass production requires larger equipment to make larger batches within less time and lower cost. The large equipment might be efficient on a per unit basis, but actually impede material flow through the facility. Traditional plant layout developers place these large machines in layouts. They proudly show us how much capacity they have, how fast they can run, and how low the cost per unit can be. However, they usually forget to mention that the large machinery is usually expensive, brings higher work in process inventory before and after, and is inflexible when demand changes, which happens regularly. Instead of the too large to be easily moved machinery in traditional plant layout, lean layouts try to use smaller equipment dedicated to each product family. Right-sized equipment is selected to suit the demand of the value streams, with quick changeover to enable smaller batch size. What's more important, they are easy to install, easy to move and more flexible to changes to demand. Factories are meant to be functional. Sometimes aesthetic considerations are allowed to override common sense. We have seen factories that are spectacularly beautiful on the inside, with large spaces between lines or machines or even with fountains, trees, tables, and chairs between machines. Usually, the excess space is quickly occupied with excess work in process inventory. The wide spaces also lock in excessive movement and transportation waste. As for the garden, in the factory people never sit at these tables chairs and they simply provide a detour for transporting goods to the next process. So, when designing a factory layout, forget aesthetic beauty and focus on function. At TXM we believe a well-designed lean production cell operating smoothly is actually a thing of beauty in itself. As we know, lean originated from Japan, with a population density of around 336 people per square kilometer, compared to Australia's 3 people per square kilometer. Factories have to organize everything efficiently on tiny space as the land is precious there, which drove Japanese factories towards lean plant layouts. Lean plant layouts usually have very little room between machines, thus preventing inventory from building up, as well as reducing motion and transportation. Moreover, when there is a waste, it becomes visible. Lean facility layout makes the flows of people, material, and information more streamlined, and uses visual controls to make obstacles and stops of flows visible. Lean plant layouts use visual controls for better communication and set visual standards. Adhesive floor markings are used instead of area painting applied on the shop floor, which makes the communication of layout changes easier and cheaper. Layout enhancement of a production plant is a common problem, so an effective layout design is important for good manufacturing of products or delivery of services. Many companies have realized that lean ideas have allowed the identification of a potential improvable element of the manufacturing process and reduced all the waste as much as possible.